Millions of viewers tuned in at once, and Hydrolix chief architect David Sztykman was behind the tech that kept the Super Bowl stream running flawlessly, even under massive pressure. And for more, we are joined by David. David, now tell us, when a major global event drives instant surge in online traffic, what's actually happening under the hood of those systems? Seems like the Super Bowl is probably one of those things where there's huge pressure. Tell us more.
Yeah, it's really difficult to manage this kind of event. Super Bowl scale is really hard in general because you can't really predict the amount of traffic that it's going to generate. And the more people are tuning into the stream, the more you need to deliver content and you need to track anything that's going on. And so you have to think about it a little bit like a distributed DDoS services, basically. Like it's millions of people tuning in and trying to get access to the same content everywhere. And so the tricky bits is really how do we manage to deliver video quality and good video quality across the internet perfectly? And that's where CDN comes in. So there's a lot of different CDN that exist in the market. And for the Super Bowl, a lot of people are using different CDN, so content delivery network. And the purpose of Hydrolix is really to be able to view in real time the quality of services that's being delivered by those CDN. So think of a video stream as a video fragment at the end of the day. It's literally 2 seconds chunk of video. And whenever someone wants to view live content, they're downloading 2 seconds video chunks all the time. And so that generates a massive amount of data, which is quite interesting to look at. Yeah.
And just expanding on that a little bit more, when it comes to the immense pressure from people streaming all around the world, what performance indicators matter the most right in that moment?
So there's a bunch of performance indicators that are really critical. One of the big one is what we call the time to first byte, which is how long it takes to actually download the first fragment of video that the browser is actually getting and rendering that video. And so time to first byte, you want that to be really, really like short as much as possible. So if we focus really on the network side of the house, you want to have a really minimum round trip time. But in general, what we focus on nowadays is more around the quality of the video that's being delivered to users. So typically, there's a concept of multiple bitrate. So a video is encoded multiple times in different quality. And what you want to check is really that users are getting the highest quality all the time and not the lowest quality. So you can see, like when you have like bandwidth issue, that the quality of the video is going down a little bit. You can see fragments that are slower. You can see that the quality is not as good. And that's really what people want to track is how much quality content is being delivered to users. And do you see rebuffering event? So is the stream stuttering on the player side is really critical for the industry.
And speaking of critical, how can one tiny code error cascade into a failure big enough to disrupt a worldwide audience?
The funny bits about that is really like at scale, everything can happen. And that's really the most difficult part is like when you have something that runs smoothly for a couple of users, it actually doesn't mean it's going to run smoothly for millions of users. And at some point, it's not necessarily just a line of code, but it's more around how do you distribute the load and how stateless is your application? Can you make sure that you can load balance across multiple services, even multiple cloud vendor to ensure high availability? And that's really the most difficult part at that scale is to ensure that you have enough capacity and that you manage that capacity well enough to distribute the content properly across data center, across cloud provider, across everything at the end of the day.
And what does it really take to keep enormous volumes of data flowing smoothly without blowing out those infrastructure costs? I imagine with something as large scale as the Super Bowl, it can get a little bit crazy.
It definitely gets really crazy for the Super Bowl. But the nice thing about the Super Bowl is it doesn't last. Like Super Bowl lasted what? I mean, total, if we look into like the pre-event, post-event and everything, it's an 8-hour event for us. And so scaling a lot of infrastructure for 8 hours is something that we can do. The difficult part is when you have to scale up all the time to ensure all the time that it's going to work and not to have the ability to scale down. But the way we designed the system was to be able to scale up different components of the system. So scale up ingest, scale up the query infrastructure, regardless of the workload. And so that allows us to scale up really quickly and efficiently the ingest, because that's what you need for the Super Bowl. But after the Super Bowl is done, you can scale down the ingest and reduce the cost of that infrastructure. And so the key part of that is really the statelessness of Hydrolix, and the statelessness of application allows you to scale up and down different parts of that application easily.
Yes, and David, just to wrap us up, we've only got a few seconds left. How close are we to AI predicting outages before they hit, and what stands in the way?
This is funny. So I would say not necessarily AI per se, but like if you look at patterns, you can see definitely things that are going to occur. Like you can see if you're running out of memory, if you're running out of resources, you know what's going to happen, right? And so by monitoring closely those KPI and seeing patterns, you will be able to predict that within a few minutes, you're going to run out of resources. So you should be able, like you should avoid and load balance properly. And so it's not necessarily a prediction per AI per se, but I think by looking really into the system and getting patterns information quickly enough, you can predict really well what's going to happen.
Absolutely. David Sztykman from the amazing team at Hydrolix, thank you so much for your time right here on Ticker.
Thank you.